digits today. Again, make sure all of your exact value stuff, if it's ever a 30, 45, 60 angle or reference angle, I'm expecting the exact answer with your hand trick. Any calculator that gives you those exact answers won't be allowed on this test, just so everybody has to know them. So first thing we're going to talk about is bearing. You see this a lot in navigation. So the bearing, it's a little bit confusing because it's the opposite of what you think about with reference angles. Reference angles are always measured from the XY axis or from the x-axis. Bearing is measured from the y-axis, the north-south line. So it's a acute angle formed by the north-south line and the line L. Notation, it can be two different ways. You could have N or S. What do you think N and S represent? North and south. Then a degree measure, then east and west. So if I said like north 30 degrees west, it means, okay, I'm starting here. If I did a north-south line, because bearing you have to have a north-south line, saying from this point you're going to go north and then 30 degrees to the west. And this would be a 30-degree angle. So saying from your starting point, which direction are you traveling? And the angle given is from that north-south line. The other notation is a single degree measure from due north going clockwise. So in this one, if I were talking about clockwise from due north, that's saying if I started here, how many degrees would I have to travel to get to this point?
330.
So you could see 330 degrees. So if it's just a degree measure, that is from due north clockwise, how far you would have to go. All right, so bearing, you have to know where you are coming from. So in all these, I want to give the bearing of point B from point A. So if I'm starting at A, trying to go to B. So first, this one we are going north. From this north-south line, it's 40 degrees east. The other notation is if I just said from due north, how many degrees clockwise, this one would just be 40 degrees. B. Okay, so to get from point A, north or south? North. From my north-south line, it is 65 degrees to the west. Or if I did the other notation, it's saying from due north, how many degrees would you have to travel? So we know all the way around would be 360. We have to back up 65, so it would be 295 degrees. All right, C. What's this one going to be?
70 degrees east.
Perfect. The other notation, Tanner, from due north, how far is it?
110.
Because we know this is 90. You have to go another 20, or you could think 180 minus 70. D. This one is going to be south 20 degrees to the west. Or the other option from due north would be 200 degrees. I did throw one more on here that I failed to put on your notes handout, but I had a lot of people asking me last semester, what if they're on the same line? So what would I say here? So if I'm talking about this one, from A to B, it's north. How many degrees do we have to travel away from this line? 0 degrees. So then you're not really east or west, so technically you could give me either. You could say north 0 degrees west, or north 0 degrees east. Or the other notation is how many degrees from due north, which in this case is just 0 degrees. So if it's on the axis, it looks a little bit different, but same general idea. All right, the key. If I give you a bearing, you have to have a north-south line. Just like when we did elevation and depression. If I say that, you had to have a horizontal. Bearing, you have to have a north-south. So we're going to take problems and try to draw pictures to solve them. Okay, so radar stations A and B are on an east-west line 8.6 kilometers apart. So I'm just going to draw a picture of this as I go. I have A and B on an east-west line, so we have a horizontal line. And their bearing, distance between them, sorry, not their bearing, their distance between them is 8.6 kilometers. Station A detects a plane at point C on a bearing of 53 degrees. If I'm measuring bearing, we have to have a north-south line. I am measuring from station A, so we have to have a north-south line at A. And we'll just draw that in as like a dashed line. Okay, so if I only give you a single degree, that's from the north-south line, we're going 53 degrees, and that'll take me to the line point C is on. Station B simultaneously detects the same plane on a bearing of 323 degrees. So if I'm measuring a bearing from point B, I just have the north-south line at B. It's still talking about C, but it's from due north all the way to that line. It's 323 degrees. Find the distance from B to C. So I am looking for this side right here. I'm going to call it X. What we have to remember, our trig functions only work if we have a right triangle. So I have to know that this is a right triangle. Have I given you that information yet? No. So we need to find out our angles to get there. What we do know is that this was an east-west line. If you have an east-west line and a north-south line, they form a right angle. So if this angle is 53 degrees, 90 minus 53 is 37 degrees. And we could use that to find this angle over here as well. Because if this is an east-west line and north-south line, how far is it from here to here? Yeah, so, well, you found this angle out here, right? You did 360 minus, okay. So that is totally fine. If you do 360 minus 323, that means this angle is 37 degrees. So if you wanted to get this one, you could do 90 minus 37 and you get 53. Okay, so if we add those up, 37 plus 53 is 90, which means angle C is a right angle. Now we have a right triangle, so we could do a trig function, just like we were doing before. The difference is, in the previous section, the triangle was given to you. But if we look at what we have, if I took my 37 degrees, for instance, from here, x is my opposite side, 8.6 is my hypotenuse. What trig function involves opposite and hypotenuse? So we could say that sine of 37 degrees equals the opposite side x over 8.6. So we can multiply over. Alright, make sure you are in degree mode. 37. So I get 5.1756. But if I want significant digits, how many did we have in the problem? 2. So if I round that to 2, it would be 5.2, and we were in kilometers here. So the trig is the same as what we had in green. The difference is reading the problem and setting up a picture. Is that one okay? Let's go ahead and look at this next. The bearing from point A to point C is north 64 degrees west. So if I'm starting at point A, if I want to measure bearing, what do I have to draw at point A? Bearing always requires north-south line, so I'm just going to draw that. Okay, so to get to point C, we have to go north 64 degrees to the west. Okay, something else I should probably mention. Are my pictures all drawn to scale here? No, not at all. So you can't ever just look at your picture and say, oh, that looks like a right angle, because we're not measuring anything here. The angle that we formed is in between the north-south line and this line. The bearing from point A to point B is south 82 degrees west. So we get point B, we go south 82 degrees west. So this angle is 82 degrees. Then it says the bearing from B to C. So if I'm measuring bearing from B, I need a north-south line at B. And it says it should be north 26 degrees east. Is point C to the east of B right now in my picture? No. So you might have to fix it. You might have to either make B longer, or I could just shorten up side C. Because we didn't measure anything, we don't know. But I know that point C has to be to the east of it, so I had to adjust my picture slightly to make that happen. And that angle is 26 degrees. Okay, so currently I have no angles inside my triangle. Then it says a plane flying 350 miles per hour takes 1.8 hours to go from A to B. If I know the speed and how long you're driving, I can get my distance. Distance is just rate times time. So all I have to do is 350 times 1.8. So this side is 630 from A to B. And we want the distance from B to C. So B to C, this is the side I'm looking for. Okay, there's a lot there. My suggestion, make sure you're drawing your pictures big enough that you can label all of your stuff. We have lots of angles and everything. If you're trying to draw an itty bitty picture, it's hard to label it. We need to figure out if we have a right triangle before we can do a trig function. So I could get angle A just by subtracting from 180 minus 82 minus 64. that angle is 34 degrees. Okay, do you have any idea how I'm going to get another angle? You have two parallel lines. These angles have to be the same, right? So we know this is 82 degrees. So this has to be 82. So these two together are 82. So you can do 82 minus 26 and you get and then 56 plus 34 is 90, so this angle C is 90. So we can set up a trig function. We can use any angle except the right angle when we do that. So if I just go with my 34, from there x is opposite, 630 is hypotenuse, so that's the sine. 34 degrees. What's my opposite side x over my hypotenuse, 630. If I did significant digits just to practice, how many was I given in the problem? 2. So if I rounded this to 2, I'd have to take it to 350. We were in miles. Have I lost you? I'm going to jump around a bit today. I'm going to do this section today and tomorrow, so I'm going to, I think I want to go to this example. So it's on the back, second example on the back of your handout. If a 75-foot flagpole casts a shadow 43 feet long, okay, this may not sound hard, but I guarantee if I put this question on the test, about a third of my students are going to label it wrong. Where does your shadow go? The ground. Okay. So here's my flagpole. And it's 75 feet tall. The shadow is on the ground. People always want to label it as the hypotenuse. To the nearest 10 minutes, what's the angle of elevation of the sun from the tip of the shadow? So from here, elevation is from the horizontal line up. So I'm just looking for this angle in my triangle. So what trig function would I use? Equals my opposite side, 75 over my adjacent 43. Remember, if you're looking for the angle, that's when you do the inverse. How do you get, I said to the nearest 10 minutes, so this is 60 degrees. How do we get our minutes? Just the decimal times 60. And that's 10.37, so that would be 10 minutes. Is that one okay? Let's jump down a couple more and do another bearing problem. So a boat travels on a course of bearing north 52 degrees 40 minutes east. So if I'm going to measure bearing, we have to have a starting point and a north-south line. And then from this point, my boat is going northeast. And the angle from my north-south line is 52 degrees 40 minutes. And it does this for a distance of 238 miles. So this length is 238. How many miles east has the boat traveled? What could we do? All I want to know is how far to the east are we, so you could make a right triangle just by drawing that horizontal line due east. And we're looking for this side. So that's opposite and hypotenuse. Sine. So the sine of 52 degrees 40 minutes equals the opposite side x. And that hypotenuse 238. How many significant digits did we have? 3. So we would just round this to 189 minutes. I have more examples. I can do more today, or we could stop and then pick up with tomorrow. Do you guys want to stop and try some, see where we're at, and then tomorrow we'll do some more? So these problems are going to be due Wednesday. So 8 problems for the next 2 days. Today and tomorrow. Technically, you do know everything at this point. I'm not teaching any new aspects tomorrow. We're just practicing more. So, you can do as many